Hey, okay, so lesson 2-2. All right, we have defining the derivative of a function and using derivative notation. So you're going to learn all kinds of cool ways to talk about the derivative, and they all have their own little special things. All right, so we got the tangent line problem, and that is really half of the calculus class, and the other class, half the class will be area. We'll get that after Christmas. All right, so then here is the definition of the derivative. Now you'll notice it looks just like the derivative at a particular point, except the a now has been replaced with x. All right, and so we've kind of looked at that already a little bit, but now we're going to be using it. All right, so I like this. If f prime of x exists, then we say that f is differentiable at that point x, differentiable at x. So this differentiability thing becomes quite an important topic. All right, so here's the notation. All right, so we have f prime. I love this, f prime of x, and that's the way you say it. The benefits are it's formal. It names the function and the independent variable. That's sweet. All right, f prime is also okay. I mean, sorry, y prime is also okay, but you don't know what the variable is, and so that becomes a bit of an issue. All right, this is a very popular way to say it, and it has lots and lots and lots of uses. This is called dy dx. You just say it just like that, dy dx, or the derivative of y with respect to x. And this little fraction thing here kind of feels like slope a little bit, and that's where it kind of came from. All right, we'll talk about it. It's very useful on some things that we're going to be doing later on. This I don't see quite as often, df dx. If the function's name is there, that one's rare. This one is used a lot. The derivative of f of x. I don't like saying it the way she said it there. I just think of this as the derivative of f of x. So d dx of f at x. I don't know. That seems a little weird to me, but that's a very popular notation. Okay, but I definitely would just call that the derivative of f of x with respect to x. That's how I would say that. All right. So then, so we're going to use this. All right. So graphically, we got the tangent line. Numerically, we can find a slope value, and then verbally, we're just finding at a particular point. Okay. So here we go on this one. So it says use the limit process of the derivative to find the general formula, dy dx, for the derivative of f of x. Now, it's unusual for them to use dy dx when they never said y. Normally, they would say f prime on this. So that's what I'm going to do too, because whatever you're given is typically the notation they're going to use. There was never any mention of a y in this function. So I'm going to say instead f prime of x is equal to the limit, here we go, you've seen this a bunch now, as h approaches 0. By the way, it doesn't have to be h, just h is typically used, okay? So it could be a lot of different things. You could call that delta x or anything, but h is popular, so we'll go with that, of y2 minus y1 divided by x2 minus x1. Okay, that's exactly what we're doing. So what we're doing is we're on the curve. Let me just draw a little picture of it here. We're on a curve, all right, and we're wanting to know just at a random x value. So that would be x, and this would be f of x, what the slope of the tangent line would be at that moment. So we're trying to find the slope of that tangent line. That's what we're trying to find. But what we're going to do is we're going to use on down the line and on h down the line to this point, which then its x value would be x plus h, and its y value would be f of x plus h. Okay. All right. Okay. So we're going to use this line, secant line, to approximate the purple. And so, but what we're going to do then is, and just like we've seen before, we're going to have H go to 0 so that this point gets pushed to the red point, and then the blue line gets pushed to the purple line and becomes one and the same. All right, so that's what we're doing. All right, so for this particular one, it's going to be the limit as H approaches 0. All right, and so f of x plus h would be 2 times x plus h squared minus 3 times x plus h all right, and then minus the function itself. So the function itself is 2x squared minus 3x, all divided by h. So yes. All right, and then we've got some algebra to do. All right, so that's where this gets a little bit heavy, but we got this. All right, so this is going to equal the limit as h approaches 0. All right, now I'm going to skip a little bit here, but we've seen this x plus h squared a couple of times. So if I do square that and then multiply it by 2, here's what you have. So you have 2x squared plus 4xh, because it's going to be a 2xh times 2. So 4xh plus, it would be h squared there, but it's multiplied by 2, so 2h squared. I'm just cleaning out all parentheses right now. That's what I'm doing. All right, so then we got minus 3x minus 3h minus 2x squared plus, plus 3x. All right, and then all divided by h. All right, now we've said this before. Everything that doesn't have an h should go away in the numerator. And let's see if that's true. All right, so we've got a 2x squared. Oh, yeah. We've got a 3x. Oh, yeah. All right, so those cancel out. And so then what remains then, they all have an h, which I could factor out. All right, so we got the limit as h approaches 0. Everything that remains has an h, so let's factor that out. And we're left with 4x plus 2h minus 3. Very nice. All divided by h. All right, and then our 0 over 0 goes away, like you've seen numerous times. Boop, boop. And so then I'm just going to finish it out. So then I can send h to 0 now that those h's have gone away. And my derivative is 4x minus 3. And that's it for example 1. All right, and so and it does say dy dx, but I really have a hard time calling that dy dx whenever the original function was not in terms of y. Okay, I know it's interchangeable terminology, but to really be consistent, I think if they start with f of x, let's call it f prime. Now, if you wanted to say, okay, this is equal to y, right? Then I could say, if I've done that, then I could say, all right, well, then that's y prime. That's dy dx. That's okay. But since they only started off with f of x, I went f prime. All right. So enough for example 1.